Hello guys, welcome back to another brand new tutorial. I hope you are doing well. Today we will see how we can calculate the hunch bar cutting length. As we already know, the hunch bar is regularly used in a box culvert. While we are constructing a box culvert, then it is very much necessary to provide the hunch bars at the corners of the box culvert. Okay, so today we are going to discuss how we can calculate the cutting length of the hunch bar. So let's start the topic. So as you can see in this diagram, we have provided here a structural arrangement of the box culvert. So here the all the corners like this one, this one, this one and this one, these corners are having hunched shape like this. Okay, so here while we are making reinforcement or binding the reinforcement, we have to provide a hunch bar. So actually the hunch bar is nothing but this type of shape. Okay, I have arranged this for your easy understanding purpose. I have incorporated in the hunch bar in this representation. So here this image is nothing but a hunch bar which is showing a hunch bar shape. So in this diagram you can't see the hunch bar, right? But in many construction jobs and regular construction field, we have to provide the hunch bars as per our design. So hunch bar is nothing but this type of shape. Okay, so I have represented here a simple diagram regarding how we can provide the hunch bar and how we can calculate the cutting length of the hunch bar. As regular BBS, while making the BBS, we have to find out the exact cutting length of this hunch bar. So let's start from the base. Okay, so here as you can see this rectangular portion is the cross section of the top slab that is in the box culvert having the top slab as well as the abutment wall, and remaining all the bottom slab having also there. Okay, so this is the top slab and this is the abutment wall. So from abutment wall to the top slab we have to provide the hunch bar. Okay, and this is the hunch. This triangle is nothing but the hunch. Okay, and we are providing here regular reinforcement steel as per our design and drawing. Okay, like 10 mm bars are provided here. Also red color bars in 16 mm dia have been also provided here, and this hunch bar is also having the diameter of 12 mm. Okay, so let's see further. Here I have provided a spreadsheet for you where you can easily estimate the hunch bar cutting length as per your requirement. Okay, so here we having the data. So here is the data chart and here is the calculation chart and some necessary formula is there and all other bend deduction chart is there, and ultimate we have a symmetric bar bending schedule chart. Okay, so let's see a step by step. Here in this data chart, as you can see, insert or edit data in yellow cell only. Okay, wherever you can find the yellow cell, that is this place, in this place, in this place, all this place where you'll find the yellow cells, then this cell have to be edited or remodified by you only. Remaining all other cells have to be vacant. Okay, no need to change or rectify all those because the spreadsheet having the calculated format. So whenever you change all those values, the ultimate result will show immediately. Okay, so here the hunch size in the data chart, there is having hunch size. Hunch means horizontal to vertical. So 300 by 300 we have taken here, and the dia of the hunch bar as we see 12 mm, which is specified also here. Then cover of hunch bar, that is 50 mm. Here the cover from this hunch bar to this concrete portion. Okay, this is the cover of hunch bar. Next, abutment wall size, top slab size, that is 500 mm and 500 mm. All I have mentioned here. Okay, here is the abutment wall size having 500 mm and here is the top slab size of 500 mm. Next, abutment cover from backfill side. This side is the backfill side, that is the abutment wall having the attachment to the ground soil. So here the cover must have to be given as 75 mm. Okay, so here the cover is 75 mm. inner side wall having the cover of 50 millimeter, bottom and top slab of the top cover having 50 millimeter, bottom cover is 50 millimeter. That is the top slab having top or bottom. If you having the bottom slab, then you have to also give the cover also as per your requirement, 50 mm and 50 mm. Okay, and the width of culvert I have taken here 5500 millimeter. Center to center spacing of the bars having the dimension of distance of 200 millimeter. Okay, I have mentioned here. Width of the culvert means the entire width of the culvert. Okay, how much the culvert length, that have to be incorporated here. Okay, next, here you have to also provide this yellow cells data. Okay, so here this bars having diameter of 10 mm, these bars having the diameter of 10 mm, this red color bars also having the diameter of 16 mm. Similarly in that here 16 mm, 10 mm. Okay, so this yellow cell have to be modified by you. That is, if you having the hunch size of suppose 900 by 300, then it will automatically calculate it as per your requirement. Okay, so for your understanding purpose I have taken here 300 by 300 millimeter hunch. Okay, so let's see some of the formulas. So here the formula we have requirement of tan theta. Tan theta means tan A. Here I have mentioned here A is the angle. So tan theta equal to perpend by base. Okay, you can see this is a prototype of a hunch whose dimension having 300 here, 300 by 300. So here also mentioned here 300 by 300. 300 is the horizontal. Okay, and 300 is the vertical. So here the horizontal part is 300, here the vertical part is 300. So suppose I have to change, suppose here 900, then let's see here 900 horizontal, here also incorporated value as 900. Okay, 900 by 300. So by the way, let's see. So here tan theta equal to perpend by base. That means this opposite side to the base. Okay, and the angle from here we can get the angle A. So angle A equals to tan inverse perpend by base. Okay, next formula we have to see cos theta or cos A, angle of A. So cos theta equal to base by hypotenuse. So from here we have the requirement of hypotenuse. So hypotenuse equals to base by cos theta. Okay, and also we have a formula sin theta or sine angle equals to perpendicular by hypotenuse. So hypotenuse equals to perpend by sine angle. Okay, just normal formula is there. Now the main aspect of this hunch bar. Suppose I am having a hunch bar here. I have taken this hunch bar to here. Okay, break this part into 5 numbers of zones. Here we have to find one zone. Here I have taken second, blue color is third, orange color is fourth, and again yellow color is fifth. Okay, so these fifth dimensions have to be calculated. Then ultimately we will got a accurate cutting length of this hunch. Okay, so for part 1, part 2, part 3, part 4, part 5. So part 1 is yellow line, part 5 is yellow line. So here part 1 is yellow line, part 2 is yellow line. Next part 2 is green line. So part 2 is green line. Okay, part 3 is blue and part 4 is orange. So part 2 is blue and part 4 is orange. Okay, so here part 1 yellow means I have mentioned here 300. So this 300 value, that means from here to here the dimension is only provided by drawing only, or if it is not mentioned in your drawing, then you can take the value as minimum of 300 millimeter. Okay, so I have taken here 300 millimeter. As this dimension is similar to that, so here also the part 5 portion of yellow line also having the dimension of 300 millimeter. Okay, so I have taken part 1 as 300 millimeter, part 5 as 300 millimeter as a minimum dimension. Now I have to calculate the part 2, which is containing the green line portion. So how we can achieve that? Let's see. Here the part 2 is nothing but here, means from here to here we have to find the length. So this length, let's see, I am saying that from here to here, Look at this portion. From here to here I have to find the dimension. Okay, and we are considering a triangle. So here I am considering a triangle. This triangle is nothing but this portion, hypotenuse portion, and we have to find out this dimension from here to here. Okay, so how we can achieve that? And we are having the angle. Okay, so to achieve that distance, we are having the entire apartment wall width equals to 500, and the cover is mentioned here 75. So from 500 I have to subtract the cover of 75 millimeter from here to here cover. Next the diameter of this red line river, then the diameter of this 10 river. Okay, then we can easily calculate from the distance between here to here. Okay, and we are having the angle of 45 degrees because here I have seen that tan theta equals to perpend by base. Perpend by base. So from here angle equals to tan inverse perpend by base. So I have formulated here. So tan inverse 300 by 300 means here the angle becomes 45 degree. Okay, so it is mentioned here. So as it is a right angle triangle, so opposite sides are of 45 degree by having the dimension with 300 by 300. If I change here, suppose here I am taking 600 by 300, then it will have an angle of 26.57 degree. Okay, see in the similar pattern we have taken dimension of this line. Okay, from here to here it has been come here by this formula. So the formula is mainly here from 500 we have to deduct 75 millimeter cover, then we have to deduct 16 millimeter this river dia, then we have to deduct K25 10 mm dia. Okay, then we have the dimension of 399 millimeter, and we are having the angle of 45 degree as we mentioned here 45 degrees. The same angle is prevailing also here. Okay, so here we have a degree of 45 degree and we having the base. So our intention is to calculate the hypotenuse length. Okay, so here from the cos theta equals to base by hypotenuse. So from here we are having the cos angle. Theta means angle here is 45 degree and base is known to us as 399 millimeter. Here 399 millimeter is the base and the hypotenuse we have to find. So hypotenuse equal to base by cos 45 degree. Okay, 399 by cos 45 degree. So that will give the value of 564 millimeter. Okay, it is formulated here. It will automatically calculate your reading as the green line having the dimension of 564 millimeter. Okay, so this value becomes 564 millimeter. So part 1 is completed, part 5 is also completed, and part 2 is also completed. Remaining are part 3 and part 4. So let's jump to the topic here, part 5. Okay, so part 5 is here. Let's see where it is having. So part 5 is considered as here. Just look at this portion here. The part 5 is this portion. This portion means from here to here. Okay, we have to find out the length. Actually we have got this value 300 millimeter. From here to here we also got this value as 564 millimeter. Okay, and now we have to calculate this length. Okay, so here just see, look at this portion. So to calculate this length we have to find out the length of this base and perpend. Okay, so if I place this triangle to this here, so what it becomes? It becomes from here to here we having the dimension of 300 millimeter as the dimension having the 300 horizontal and 300 vertical. Okay, so here same, from here to here is the 300, from here to here equals to 300, and we have to find out the value of from here to green line cross section. Okay, so and we are having the haunch cover as 50 millimeter. So if I deduct from 300 to 50, then it will take the charge of 250 mm, right? Here if I deduct this cover portion 50 mm and also this cover portion 50 mm, we will able to get the dimension of here to here and here to here, that is 300 by 300. That's mean it will having the dimension of 250 mm by 250 mm triangle, similar triangle. So that is only I have shown to you here. Okay, haunch portion. So the value of from here to here we have got is got as 300 minus of 50 mm, then 250 and 300 minus of cover 50 mm, that is from here value here to here it is as 250 mm. So from this similar triangle we are having the formula of hypotenuse square equals to base square plus perpend square. Okay, this is the formula. To calculate the hypotenuse value we have to square root of this whole terms of base square plus perpend square. So that value I have formulated here, square root of base square plus hypotenuse perpend square. So it will give the result as hypotenuse of 354 mm. Okay, so from here to here the dimension having the 354 mm we got. Okay, next, and this is the last portion. So here what I have to do, here the dimension we have to calculate. So similarly in case of earlier stage we have found this triangle, so here also I will get the triangle to project here. So I have provided the triangle here and this dimension we have to calculate. Okay, this dimension. So similarly we have to calculate, as the angle is 45 degree which is mentioned earlier, we have to calculate this length, this dimension. How we can get? We get easily by topping the top slab value, that is top slab having the dimension of 500 mm, by deducting this value of 50 mm cover minus of the diameter of this river 16 mm and minus of the diameter of this 10 mm river. Okay, so it will give the dimension from here to here. Okay, so that is only we have incorporated here, that is from 500 I have deducted the value of cover, top cover 50 mm. Next I have deducted the diameter of the main river 16 mm. Then I have also deducted the transverse rivers of 10 mm. Okay, so it will give the dimension of 424 millimeter. So by this 424 millimeter we are having the perpend value, and that is opposite side value having the dimension of 424 millimeter, and we are having the angle of 45 degree. So as we know, sine angle or sine theta equals to perpendicular to the hypotenuse. So hypotenuse equals to perpend by sine angle, or here sine angle nothing but sine 45 degree. So hypotenuse equals to perpend, we have the value of 424 and sine 45 degree value we have to just calculate. So by incorporating all this value, and we will get the value of orange line as 600 mm. Okay, so this line portion having the value of 600 mm. So finally we got the entire dimension like 300 mm. Next the line value of 564 mm. Next blue line value of 354 mm. Next orange line value of 600 mm, and ultimately at last we got the value of 300 mm. Okay, so if I add all those values from here to here, then we will get the total length of 2117 millimeter. Okay, now from here to here the entire length is equals to 2117 millimeter. Okay, right? But here is the bend. Suppose actually this line, this bar is actually in a straight shape, but we have to place it like this. Okay, so some bending is occurring. Okay, so that bending due to which the elongation of this bar can takes place. that elongation of this part we have to deduct. So as it is a, suppose it is a right angle triangle, okay, and this value, as we can assume at 45 degree, this value we can assume as 45 degree. So for 45 degree making angle, we have to deduct the value of 1d, 1 times of d, where d is the diameter of the bar. So here the diameter of the hunch bar having 12 mm, so 1 times of 12 mm for each bend. And here we are having also a bend here, okay, here. So here 2 bend are there, so 2 bend we have to deduct, okay. Similarly, for if we are having the bend at 90 degree, then we have to deduct 2d value. For 135 degree we have to deduct 3d value. For 180 degree we have to deduct also 4d value. So here total length having we got 2117 millimeter. For bend deduction of 45 degree bend, we have to deduct 2 sides of 1d, 2 times of 1d. Here 1 bend and here is also 1 bend. So here 1d. Here you can see 2 times of 1d, where d is the diameter of the hunch bar. So 12 into 2, that is 24 millimeter. That value we have to deduct. So ultimate total length, gross cutting length we got it as 2093 millimeter. That is 2093 millimeter. Okay. In terms of meter, we got it as 2.09 meter. Right. So finally, we got the cutting length of this hunch equals to 2.09 meter. So for each hunch bar, we are having the requirement of 2.09 meter length of 12 mm diameter. Okay. So here the ultimate 2.09 meter is the length of this 12 mm hunch bar. Okay. So here is the bar bending schedule. Here description is Culvert LHS. Okay, Culvert at LHS means left hand side. So here is the Culvert and we are considering the left hand side. So I have mentioned here as Culvert at left hand side. Description is hunch bar and shape of the bar is like this, who's having the length of 300 millimeter here from here to here, 300 millimeter from here to here, and this length is equals to 1517 millimeter. Okay, die of the bar for hunch bar equals to 12 millimeter. And numbers of bars, how we can calculate numbers of bar? Because we are having the width of the culvert is here 5500 millimeter and the spacing equals to 200 millimeter. So center to center spacing between the hunch bar is 200 millimeter, and ultimately if we divide with the entire width and we have to add plus 1 extra, so finally we will get the value of 29. Okay, and the cutting length in meters equals to 2.09, which is already we have calculated. So total cutting length is nothing but the product of 2.09 meter multiplied with 29 numbers of hunch bars. Okay, so it will give the result of 59.66 meter. Total cutting length equals to 59.66 meter of 12 dia bar, and for 12 dia bar we are having the unit, that is per kg weight per meter equals to 0.89 kg per meter for a 12 dia bar. It will give the entire product of 0.89 to the 59.66, that is entire total cutting length. It will give the value of 53.03 kgs of steel. So you can finally get the gross weight of this steel equals to 53.03 kg for culvert section of the LHS side. Okay, so by this way you can easily calculate the dimension of the hunch bar. So by this 300 by 300 hunch, we have calculated the length, actual length and weight of the entire hunch. Okay, another length of the hunch bar, like if you were having the hunch size equals to 600 by 400. Okay, and if you are having the diameter of the hunch equals to 10 and cover is 50, abutment size all are same, so it will give the result of gross cutting length equals to 2.48 meter, and it will give the hunch bar equals to kg weight equals to 43.56. So by changing those values as per your requirement or as per given in your drawing schedule, you can easily calculate any haunch size and shape of this haunch and easily prepare a BBS by this method. So alright, this is it for today. If you want this Excel sheet, then please drop your email IDs in the comment box. I will definitely send you through this mail. And if you have any question or queries regarding this, then please ping me in the comment box also. I will definitely try to solve your queries. If you feel this video helped you a little bit, then please do like, share and subscribe to this channel. See you soon in the next one. Till then, thank you all.